Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life at home.
At home. Okay, Jam, I gave you some instructions.
Yes, you did.
Do you want to tell me what you did for your experiment this week?
I'd love to. So I took some milk. Not sure if it matters, but it was 2% milk. I put it in a kind of wide-mouthed, short Pyrex glass dish. Took some food coloring, a couple different colors, dropped it all around on the milk, in the milk, I guess is the right way to say that. and then, per your instructions, I put a very small drop of dish soap and had it go right into the middle of the dish of milk.
Okay, and what happened?
It was so weird. Yeah, nothing happened. So anyway, bye guys. No, it was very cool, actually.
Even if nothing happened, though, that is an observation, and you can learn science from nothing happening, just for the record.
I can't wait until you throw that curveball at me. You give me all these very elaborate instructions of things that don't actually go together at all. You're like, so take a washer hose and some vinegar and some WD-40, a can of Dr. Pepper, some Alka-Seltzer, 3 ball bearings.
Man, you can do some crazy stuff with that.
Vegetable oil. And you just we combine all those things, and then nothing happens. And you're like, all right, well, it's chemistry. Sometimes nothing happens. I'll just be so disappointed. I'll be like, oh my gosh, this seems like it's going to be a really cool experiment. And then nothing happens.
That is true. Sometimes nothing happens, and it is disappointing in chemistry, in science research, etc. However, I don't think children is the right age to teach that lesson. You got to learn to like it before you can be disappointed by it.
Right. Yeah. So it was very cool what actually happened in the real experiment that you really had me do, not the fake one I was just making up. It was like an explosion of color. It was the soap hit. It was just like, and all the colors kind of like started moving first like away from the soap, and then it was kind of swirling around itself and kind of like, yeah, it just looks like it was just swirling everywhere. I don't know. It's kind of crazy. And it kept going for a while. I mean, it slowed down, but it was really just like, it kept moving.
Right.
And stuff. It was very surprising.
Well, do you want to take a guess at what's going on with that?
I did have a guess. I think it may not be related, but I remember when we talked about soap and grease and stuff way back at the beginning of the podcast, where I can't remember all the details we talked about necessarily, but we talked about, I just told you an observation I've had where when I've noticed like a really greasy dish that might have like a little bit of water in it in the sink, you can kind of see that film of grease or whatever on top. And I told you that I'd like to like do a drop of soap and watch it just go whoosh and like scatter away.
Right.
In almost like it seemed like in fear of the soap, you know? And so I've always done that.
Terribly wrong.
I've always done that just to make doing dishes a little bit more fun. So in this case, I thought maybe that was something to do with it, because the similarities are that they're soap, obviously. And
right.
Milk isn't grease, but it is definitely fatty. I mean, I don't know exactly the right word for that, but we talked about even its molecular structure helps in the case of like eating something spicy, because it has a more lipid-y content to it or something. So I wondered if like the hydrophobic thing played into any of this. That's kind of as far as I got. It
does. You're right.
Like, those are like some puzzle pieces I can point to and say I think these work together, but I don't exactly know how, I guess.
Well, I'm going to say that you can sum that up by saying it's the return of intermolecular forces. So we've talked a lot about how soap works. You kind of mentioned it. You guys can go all the way back to our very first episode, and more recently had an episode about how soap kills COVID-19. So soap very basics of soap is that it has one side that is polar or charged. You can learn more about what that means in depth in those episodes. And it has one side that's a long chain of non-polar, non-charged neutral. Mm-hmm. So it is almost like half one way and half the other. Mm-hmm. And fat and grease are non-polar, so they want to stick to the non-polar side of soap. Mm-hmm. And the charged particles, the positives and negatives, the charged part of soap is going to be attracted to the positives and negatives in water. So water is also polar, and the proteins in milk. So when you drop that soap in, you are watching the interaction of the molecules. You're watching the intermolecular forces at play. So the soap is trying to find the fat molecules with one side and the protein and the water molecules with the other, and so it's all moving around, and the food coloring is moving with it, and so you get to see the movement that happens from the addition of a new molecule into the system and all the molecular interactions that are going on.
Yes. Dang.
So you're watching the intermolecular forces. I mean, obviously not a molecular level, but you're seeing sort of the result of all those molecular interactions.
So if you hadn't put the food coloring in, would it be super hard to even tell anything's happening?
Probably so. I mean, maybe you could see that it was moving, but you might even just think it was moving because you put a drop in the middle.
Right.
But I've never tried it without food coloring. So if you're doing this at home with a kid, I suggest that you kind of do exactly what I just did with jam. You can put the food coloring on, ask them, what do you think is going to happen? I didn't get to ask him that because he was doing it without me. After it happens, you can ask them to tell you what's going on and basically encourage them to make observations. Oh, it's still moving. It slowed down, but it's still moving. All the colors spread out. Then you can ask them what they think is going on. And they're probably obviously not going to get that jargony language unless you're doing it with someone who's already been in some chemistry classes, an older kid, maybe a teenager. But they can talk about, the soap moves the milk around, and any kind of conclusion that they come to about why that's happening is getting them to think critically about what's going on, even at a young age, even if that answer doesn't exactly line up with the jargon. If they're making accurate statements about trying to figure out what's going on, that's a good place to start for kids. Yeah. And then let them, as always, try new things. So they can say, what's going to happen if you do this without food coloring? Kids love food coloring. So usually the question is, what happens if we do this with all the food coloring? They do that a lot. So you can try that. You can get them to try it with different liquids. You can say, do you think this is going to happen in water? I think if you did it in water, it'd probably be pretty boring. You could try it with different kinds of milk that you have at home, or heavy cream, or anything like that. You can try it with different kinds of soap, hand soap, dish detergent, anything like that. You can try drizzling the soap or putting it on a Q-tip and putting the Q-tip in and moving the Q-tip around. You can try all different kinds of things. So I would let them ask questions. What if we do this? Can we do this? And my answer when I'm doing these kinds of experiments with kids is always, yep, let's do it. Anything you're interested in trying and seeing what happens, that's an investigative mind at work. So we want to encourage that. So definitely let them do that. If they want to try it over again and put different kinds of food coloring around. And while this is happening, you can ask them, what do you think is going to happen? Wow, that's cool. Wow. Do you want to try something different? Oh, I like that idea. Be very encouraging, ask a lot of questions, get them to practice verbalizing why or what they think. And those are good ways to do science with kids. Also, a fun fact, we did this at my college graduation party. So at my college graduation party, I had set up all these little experiments. I think there was a slime setup, and I don't remember all of them, but that was the first time I did this experiment with the milk and the food coloring. And it was really fun. And the college graduates loved it. The people in college that I invited to my graduation party loved it. So I think maybe teenagers will think they're too cool, but this is a fun one for any age. I mean, Jam had fun doing it, and he's a dad, so.
Yeah, absolutely. It was a lot of fun. I definitely would like to maybe try it a few more times too, and try different things if I get time. There's like, just like you said, I mean, you start to think of different things to do. Like, I'd love to try it without the food coloring and see if I can notice any changes if I look really closely. Or just try different combinations of colors and stuff. But because I didn't know exactly how it was going to work, I just picked some random colors and stuff, and it might be kind of cool to see if would be some that would blend together well or whatever. But yeah, it was a lot of fun. I think even teenagers, if they'd let themselves just try it, would have fun doing it.
I think so too. Also, you can try different types of food coloring. Maybe gel food coloring would move differently than the ones you drop on and stuff. There's lots of fun things you could do. Great. Well, chemistry's cool. I'm glad you had a fun time.
Absolutely. Thanks for teaching me, or I guess first just sending me on a wild experiment and then teaching me later.
Yeah, I think this is a fun way to do it. We're, like we said, we're open to any kind of feedback that you guys give, but I really have enjoyed just telling you to do an experiment and then seeing what happens.
Me too. It's actually kind of fun, especially because like I don't have to wait too long to have it be explained, but it's pretty fun just not knowing anything ahead of time. It's like as if you were just kind of giving a chemist like some instructions and no information. Like normally I shouldn't really do a lot of experiments, but these are all safe ones. And I just don't know anything. So it's so great to just be totally blind.
Yay. Thanks for having a good attitude about it. And thanks to all of you guys for listening. Let us know if you have any ideas or if there's any experiments that you've already done with your kids that you'd like us to go over. We'd be happy to do that.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. And we'd like to give a special thanks to E. Robinson, who reviewed this episode.